All right, so I'm going to start the recording. I'm going to share my screen with you. And I'm going to give you some basic background information on confidence intervals. So that's my number one objective for tonight. One of the things that I want you to understand is confidence intervals, whether there's three generic or general confidence level intervals that we use. So if we have a proportion, that means that we have counted data. It's counted information. It's discrete data, basically, is how we look at it. We're looking at a p hat plus or minus a critical z value times the square root of the p hat times the q hat over n. And I'm going to show you what that looks like in a question. So hang tight. If sigma is known, then we use a z confidence interval. So in calculators, it'll show as z interval. And the formula for that will basically be a mean plus or minus the critical z value times the sigma over square root of n. The third type, which we're not going to actually talk about today, I think today we only do the first two types. The third type is when sigma is unknown. Sigma is unknown, and in this case, we're using S of x as our standard deviation. And in this case, we use what's called a t interval. And there's a key to this one that I want to make sure you hear me out, just in case you run into it before I actually go over this concept. And this is basically the mean value plus or minus the t critical, which is basically the area and degree of freedom, and that is times S of x over square root of n. So right now we're only focusing, I believe, on the first two because they're going to give us S of x or sigma, lowercase sigma. Okay, since we're only focusing on these two, I want to talk about the critical z values. So look at where I'm highlighting. Okay, those are critical z values. You can actually look them up. And what you need to remember when we deal with this is that confidence intervals are always two tails. What does that mean? So what it means is that alpha, if you notice each of these alphas is split in half, right? You notice that there in the bottom? So if I'm looking at, say, 90% confidence, the area which I look at, okay, so look at the diagram that I'm about to throw at you here. All right, so there's my chart. Here's 0.90 or the 90%. Notice that the 10% gets split in half. So this is really 0.05 and this is 0.05. All right, for a total of 95. So 0.95 is the area that I'm going to look up when I do the z interval. Okay, so what this means to me for 90% confidence, for example, if I go to Excel, which we would use then norm S inverse, let me pull it up so you can see what I'm talking about. All right, so take a look here for just a second, and you'll notice that I'm going to go with equals NORMS inverse because I have the area. I'm going to put in 0.95, and that tells me that the critical z value will always be 1.645 given an area of 95. So if you notice, if I shrink this, my Z value equivalent is what I use for 90% confidence. Okay. The next very common confidence interval is 95%, which obviously 5% split in half is 0.025. So here, I'm going to look up equals norm S inverse again, but this time I'm going to put in 0.975, which means that this Z equivalent is about 1.96, and that does not change. So once you know that, that will always be the value that you're going to use as your critical Z. So remember, this is Z critical. What we mean by Z critical is that it is the cutoff of our confidence interval. If I do the same thing for the 99%, which is the other commonly used confidence interval, again, for this, the 1% gets split in half and added to the main area. So that's 0.995. So that becomes equals norm S inverse of 0.995. And you get a Z-score, as you can see, of 2.76. Obviously, you want to maybe shrink this in. Oops, too far. And that's your Z critical. So please take a picture of these or write them down. That will never change. That will be what you will use every time for that critical value. And again, what did I say about confidence intervals? I said that they are always two-tailed. That's why we split the tail in half. So if you notice, this 90% means that 10% of alpha is remaining, which I'm going to split in half, leaving me 0.05 for the left and the right. Here I have 5%, which I'm going to split in half, leaving me 0.025. And for this one, I have 1%, which I'm going to split in half, leaving me as a decimal equivalent 0.005. So that's how I'm getting the tail. So if this is 0.005, the center value holds 99% or 0.99 equivalent. Above it is another 0.005. So when you add all that up, you should get 1 for an answer. Okay, and that's why when I did this, I'm just going to write it down so you have it. I did norm S inverse, and I'm putting in 0.995 because I'm in essence adding up these two numbers. Okay, any questions so far? Or is that making sense? So far, so good?
Yep.
Okay, so please remember these, write them down, and we'll go from here. Once you have them written down, I'm going to go ahead and move forward with this. Take a picture if you have to make it quick. I'm understanding this, that we're ready to move on, so I can go into Alex and we'll do a question together.
Yes.
Okay, the other thing I need you to really take home is the formulas. Please take a picture of this if you have to, or write it down, because you'll need this as we move forward with the questions.
Yeah, critical Z value, that's a Z, and then what is that before the 2?
That's the alpha that remains split in half. So if you remember when I did, for example, 90% confidence, I said to you, well, there's 10% alpha, right? Alpha is 10%. In other words, 1 minus the 90, but it gets split in half. Remember I said that? So that means that this is 5%, 5%. So I reduced it to a decimal of 0.05. So you have, if I were to draw it out, the 90 is sitting right in the middle. Here's 90%, right? And up here you have 5. And over here you have 5%. So it's always two-tailed with a confidence interval. Never changes.
What is that symbol there after the Z?
Alpha? Alpha. This one right here?
Yeah, it looks like a 4 with a circle to the side of it.
Yes, no,
I'm
that's
saying it's
alpha.
alpha divided by
It's
2.
Alpha divided by 2.
That makes more. Yep. All right.
Jeez, making
Thank you.
fun of the teacher. Jeez. It's a rough
you.
crowd, rough crowd. So yes, it's alpha divided by 2.
Hi, Miss Marie.
Hello?
I made it.
Good. So Z alpha divided by 2. So yeah, if there's anything else that you're not following, let me know. All right. So you got the formulas. You got the critical values that I showed you. And now let's look at a question or two. Hopefully by the end of today, you will have everything completed. That's the goal, okay? So, all right, over here, I just want to restate, again, I sound like a parrot. Jeannie, that wasn't directed at you. I know you have parrots. This is intended just to reinforce the fact that confidence intervals are always two-tailed, always. So you always take that alpha and slice it in half. Okay, this is alpha. Looks like a fish, I guess. If you're a kindergartner drawing a fish, that's what your fish would look like. That's alpha. So whatever alpha is, in other words, whatever the area is, if you notice, my area becomes 0.95. Once again, I cannot stress enough. If you look right here, there's your 90%. All right, here's out the first half of the alpha. Here's the second half of the alpha. But when I look up the critical Z, which is this funny looking symbol that I drew here that someone was making mockery of me, that's what it looks like. And it's basically this area. It's 0.95 for this example. And I showed you on the previous slide with Excel, these 3 values, which are crucial for you to know because they're not going to change. They're not going to change. Even when we get into hypothesis testing, that's not going to change in the two-tail. Okie dokie. I'm moving on from here. Are we good? Not good? Thumbs up if you're getting it. Just give me a thumbs up on your screen. I can see everybody. Okay. Okay, so what is the issue if I don't have a thumbs up? What is your issue?
Okay, I'm looking at this, and this is my Excel table. Am I right?
I'm on Excel, correct?
Okay.
So what I need you to do is to, at this point, write down what you see here. So if they ever ask you for a 90% confidence level or confidence interval with 90%, that critical Z is going to be 1.645 and it never changes.
Okay, that's 90%, right?
90% confidence.
Okay.
And
confidence interval.
If instead the confidence interval is 95%, we are going to focus here as Z critical at 1.96. That's never going to change.
Okay, 1.96. I got that.
And I have a confidence interval. What is that pen? That is so weird.
Confidence interval 95%.
Right. If the confidence interval is 99%, so that means it's very narrow. If I'm 99, well, actually it depends. It depends on the sample size. That means that I'm only leaving a very small margin of error. In that case, my Z critical is 2.576, never changes.
This is critical. Wait a minute. Oh, this is This is Normus
Normus inverse. Normus
IN.
inverse, but don't confuse apples and oranges. When I did Normus inverse, and you'll see that when you revisit the video. Remember how I said to you in the previous example with 90% confidence?
Mm-hmm.
You remember how I said to you the 90% is in here. If I take the alpha and I split it in half, which in our case is 0.10 divided by 2, in that case, you notice I have 0.05 on the right and 0.05 on the left.
Divided by 2.
Okay, and what that means for us,
by 10 by 2. 0.05.
what that means for us is that if I go into Excel, okay, notice that I'm going to go equals NORMS. So I want this one. I want this guy, Normus inverse.
Okay.
And notice how it's asking you for probability. So I'm going to put in this case, 0.95. Because I'm adding that middle chunk in the first chunk. Hence 0.90 plus 0.05, which is 0.95.
Okay. Do you have to put another parenthesis around the 95?
You would.
Okay.
Sorry, I'm taking attendance real quick while I'm talking.
Thank you
All
for
right.
waiting for me.
And the
So,
95 comes from the 90 point and the 0.05, correct?
Correct. You're adding the two chunks.
Okay.
Now, once you do that, notice our value again. Like I said, this will never change. Check it out. You see how you get 1.644854?
Mm-hmm.
But round it to 3 decimals, you're back to exactly what I stated up here, which is
1.645.
Mm-hmm. So I've already done the work for you in terms of that, but that's how you obtain it. So if you notice for the 1.96, if I do the 95% just to restate the obvious here, I'm going to take that 0.05, which is 5%, right? 100 minus 95 is 5%,
Mm-hmm.
which is converted to a decimal is 0.05, right? Right?
Mm-hmm.
Divided in half, that means that this is 0.025 on the right, 0.025 on the left, and in the center, 0.95. So now when I look at the normal distribution, I'm adding those two together, which come to 0.975. That's never going to change. So once you know it, you know it.
0.975.
Now, equals NORMS inverse. I don't think so. And we're going to put in 0.975. All right, are you with so far, everybody? Is there any other questions that are coming to your mind?
Mm-mm.
Okay, and when I hit that, you see how we have 1.959964, which obviously I want to
9.5.
shrink to 1.96, which again, look up here. I already did that for you.
Yep. That's the critical.
All right, I think I heard. All right, so that's good. All right, so let's go into the first section in ALEKS, and let's talk about the questions one by one. Let's be patient with each other. Everybody's going to be in a different place, knowledge-wise. So be patient, and we'll get everybody's homework done together. How's that? Sounds like a plan? Don't all talk at once, right?
Yep.
All right, here we go. We're going to do first the confidence interval for the population mean. And let's see what they're giving us. So remember, we're looking for them to give us the standard deviation of the population. Remember I said that at the beginning, because that makes a difference whether it's a z-test or a t-test. Okay,
Shell.
all right. So what else do we notice?
The standard deviation of 106.
Standard
Yeah, we're gonna need
deviation is
that.
equal to 106.
Right.
Okay, and what else do we know?
Sample of 90.
Sample size of 90. So that is all we need. We have everything we need to do the
And
math here.
90.
And this is the second formula that you wrote down?
That's the
That we're gonna
second
be
formula.
using, because the first one was proportion, so the
Well,
second would
that's
be for the
next.
mean.
That's coming up
Oh,
next.
okay. Okay.
Deviation.
So let me just also remind you here. Notice that it says carry your intermediate computations to at least 3 decimal places and then round your final answer. This is a key. Round your answer to 1 decimal. Okay. So let's do this together. I'm going to work it out with you. All right, ready?
Mm-hmm.
Let's go to our formula sheet here. So I said this is going to require the mean plus or minus the critical z-value. Notice that's a critical z-value times that standard deviation over square root of n. Now notice that they did tell us that this is a population standard deviation. So again, we have the mean, we know is 1800. The confidence level that we're looking at is 95%. What is the critical value?
Is it it's not the 106, is it?
1.96.
1.96?
Yeah, so that's the critical Z.
Okay, wait a minute.
We have
X equals
the standard
1800.
deviation. You told us that was 106. And we have N, which is equal to 90.
Z equals 1.96. Is that 2 over 2?
That's alpha over 2. Alpha over 2.
Oh, alpha, alpha.
Yes.
Okay.
So now we have 1800. I see you laughing, Ryan. I got you. I got your number. Okay, I'm kidding. 1800 plus or minus the critical value, which is 1.96, times the standard deviation, which is 106, over the square root of 90. So I'll color code everything for you. Follow me to America, you'll see the connection. Look at the
106
formula.
Over square root of 90.
If you follow the color code, if worst case, that'll help you, since apparently my writing is not up to par.
Is the square root of 90 45?
No, you have to use the square root formula.
Okay.
And so I'll just circle this part here. Where is that? That's right here. All right, are we good so far? Are we
I'm
able
trying
to
to get it.
follow the color code?
Yeah.
Yes, we're good. Okay, wonderful. Yes, take a picture of this as worst case or write it down, your choice. Okay, now the calculation here. I believe that you have a calculator. Can I get
Mhm.
one volunteer like Jeannie? Or somebody who I know can do this already, has done this already, to do the calculator and show it on the screen?
Yeah, I can do it.
That'd be awesome. All right, let me make a co-host. Host to the most. All right.
I have to get in my Alex and get the.
Yeah, you
Calculator.
just need your calculator. And you wrote down all the numbers, I hope.
Yeah.
Oh, awesome.
Hang on 1 second. Let me get in my Alex.
Make sure you have this written down because this is a good start. to this question, and then we can do some more, and you'll feel like a pro by the time we're done, hopefully. That's our goal.
Hang on one sec. Can I just get the calculator, or can I, because it's taking me to old stuff, let's see.
I'm not sure.
All right, let me share my screen. Hang on.
Awesome.
Can I click on that, start knowledge check? Will that take me to something, or?
No, you need the calculator.
Yeah,
Don't do that. Don't start the knowledge check.
yeah. All right, let me go to assignments.
Oh, that's how we get that.
Yeah.
Oh,
just
that's
go
how
in-
we get that.
I owe something for class 4, so I'll just go in the calculator for class
Okay.
4.
That's fine.
All right, so
1800
1800
plus or minus
plus or minus
1.96
1.96
times
106
106 divided by,
divided by the square root of 90.
so put square root of 90, and look at this beautiful calculator. Hit equal. And there's your answer. So if you recall, in this question, they wanted 1 decimal place, so this would be 778.1.
So you're
And
lower?
1,821.9.
I have
Because remember, they only want 1 decimal place.
Equals 1,821.
821.9. But that's for this example.
I have a question about the
0.21.
calculator. So I have a TI 83 plus.
Oh, let
I'm
me
not
show you
seeing-
that one. Yeah, let me show you what
Okay.
that looks like. You're gonna love this. So let me steal my screen back. All right, and so let me go to the calculator itself. So if you happen to have this calculator, this is the time to whip it out, because this is when we really need to save ourselves. Look at how easy this is gonna be with the calculator. So in your calculator, do you know where the stat key is? I assume yes. Go to stat and go over to test.
Stat pilot.
Okay.
Okay, if you go all the way down, you see how this is the interval?
Yeah.
Hit enter. Obviously you want stats.
Okay.
In the standard deviation, we had 106, so you'll put 106. The mean that's given to us is 1800. The sample size is 90. And we want 95% confidence, so just leave it at 95. And go ahead and
And
hit
hit calculate.
calculate. Hit calculate and look at your answer.
That's ridiculous. Okay.
So it makes your life very easy. Now you see the formula, you see the calculator, and you see how you can actually do this as well. You can actually do it on a regular calculator, as we just
Mine
showed
was a
you.
little different. I have the TI 84 plus, and it gives me a different list of what you had.
Okay, what is yours here? Yours is not online, right?
It says the standard deviation, and then it says a list, and then it says frequency or
No, that's because you're in the wrong tab. So let me go back. I want you to notice something. Do you see this?
yeah,
Do you see this?
yeah.
So you need to be here.
Oh, on the stats, and then
Yes.
click enter at
Hit
stats.
enter. Hit enter.
That's stats.
Okay, I got it now.
Yeah, go ahead. I'll give you a second. Go ahead and go put in your data
Okay.
Mhm.
and let me know
This
what
is-
you get stuck on.
This is wrong. Mine is
A lot of people
wrong.
are doing that. Is there not, I like this method, but is there not a plus minus button like it had on the online
You don't need
calculator?
it. You don't need it. Go
Right.
ahead. So you'll see what I'm saying. It'll automatically, once you're ready, let me know.
Oh,
Oh, I was able to find it. Yeah, I
I
did it on the
found it.
calculator, how you showed. Yeah.
It does it right away.
Yeah,
Right.
I got it.
let me go all the way down.
You hit enter. Are we good?
Yeah, thank you.
What we go over to? Calculator.
Okay, so where are you? You're gonna go to stat?
I'm trying to, I got stat.
Tommy? Okay, go over with the arrow key to test.
Oh, okay. I got it.
Now scroll down with the
To
arrow
Z
key
interval.
to Z interval number 7, hit enter. And then
Enter.
make sure that you're on stats.
I got it.
Okay, excellent.
Okay.
Now put in your numbers.
Now I got, go over to stats.
Yes,
Okay, I got, now go down.
you got your numbers though? You gotta put your
No, no,
numbers in.
Wait a minute. Okay, and wait a minute. Mine say L1 list.
Okay, you need to move over to stats.
Yeah, that should be data.
You're in data right now. That's why it's telling you L1. See how this says data
Okay.
and that's stats? I want
Yeah.
stats. So
I got it.
Okay,
I got it. The 106, and then we go down.
yeah, with the little arrow key, go down 1800,
1800.
go down again, sample size 90,
Okay, go down again.
and then put in 0.95. I need you to edit this video. I have a little blurb, but I need to edit it.
Okay, I got 90
95 for the confidence level. Thank you for the confidence.
and 90 and 95, and go down to calculate
Calculate, yeah.
and hit enter.
Mm-hmm.
1778.1
Look at you.
1821.9.
9. Look at you.
Is that right?
Yeah.
Oh my God.
Now, that may not be your answer for your question. I hate to say that, but what I need you to do now is let's look at another question. Let's see if, you know, it's similar to this. So I would put in my answers into the lower and upper. Remember, your lower numbers are always going to be the smaller of the numbers you get. The upper will always be the higher of the numbers you get. So that's where you do there. All right, shall we do another?
0.9.
Yeah,
Yes, please.
okay.
Yes.
Let me,
Please.
I don't know what's going on here. Hang on a second. I think I just lost it. Here we go. Here we go. I'm telling you, by the time you leave with this class, you're going to be in great shape. All right, here we go. All right, so let's do another question just like that. And again, remember you're doing the questions involving means. Okay, so when you look at this question, most of you get a little nervous, right? Because you see that E, MEQ over L. Oh my God, it's a bunch of nonsense what it is. You don't even pay attention to it.
You're not
Tell
sharing.
me, I'm not.
No, ma'am.
I don't want to share anymore. You're being people and being mean to me. They tell me my alpha over 2 looks like a 4. All right, just kidding. All right. Tell me, what is the sample size?
Is it
What is the sample?
100?
100.
100.
Okay. What's the average? Where do you see the word mean or average?
I'm trying to see.
It's 101.
101.
Yep. So our sample size is 100. We know the mean is 101. What's my standard deviation?
36,
36.
And what confidence level do we need?
95%.
95%.
95%.
What does that mean to you in
Is it
terms of that critical?
1.96?
It is that Z is equal to 1.96. Very good. All right, let's go. Show me what you got.
So I
Use
got
whatever
some-
method you want, or if you want, I'll throw it into the formula. We could do that.
I have the answer.
Go ahead, Jeannie.
It's 100.9 and 101.1.
Okay, let's see if she's right. Everybody, let's prove her to be right.
Okay,
So
we in
our-
stat.
Yeah, our formula is 101 plus or minus the 1.96 times the 36 divided by square root of 100. That's what your formula should look like. So check yourself, get used to writing it out. I don't care if you're using technology because it helps you to do that. All of this, by the way, just for the record, all of what I'm about to highlight here in yellow, all of this is your margin of error. Okay, and I'm gonna explain that real quick, what that means to me, you and to me. So I'm gonna throw this into the calculator. And you guys are gonna do this on your calculators, whatever method you're using.
I got stats.
Okay,
Guess 36. Okay.
go to test. Are you in test?
I'm at stats. I
Okay.
got 36.
Oh, no. Stop for a second. Stop and listen to what I'm asking you.
Go ahead.
Back, go to stat and go to test on the top.
Okay.
Scroll down to
Hit
Z
enter.
interval.
Wait a minute. Go back up.
Stat,
Enter. It ain't
go over to test. Can you-
acting right.
Okay, you need to
Wait
go
a
back.
minute. Wait a minute. Stats.
Mm-hmm.
And go over to test.
Go over to test,
I did.
come down to Z interval.
Okay.
Hit enter. And it should look like this right now.
Enter.
The stat should be the one blinking.
Yes, ma'am. I have it.
All right, so the standard deviation is 36, the mean is 101. The sample size is 100. Confidence level, no change, right? And you want to go down to calculate,
Enter.
enter, what you get. I got something different.
it's
Jeannie.
Not 1.96 is not
93.
the confidence level?
93.944 and 108.06.
Yeah, that's what I got. So let me see what
Yeah, but
happened.
I put the 1.96 in at the confidence level. We don't have to do that.
I don't know
You
what
just put the
calculator you're using.
0.95.
Use the same one you are.
And X
Okay, so you don't
X
have
is
to. you
101.
actually-
and
don't have to?
sample mean is 100.
Okay, so look at my numbers.
Yeah, I got it. All right.
So when you recalculated that, what did you get? Did it change?
0.95 or just 95?
I just should just say, I forgot what it looks like. Hang on a second, let me just pull it up. Yeah, 0.95.
I'm getting 90. I'm getting 93.9.
944
That's correct.
That's right.
Have you look up?
and
up-
108.06.
Oh, I got that. Okay, 108.06.
108.06. And that's your confidence interval. That's your upper and lower.
Okay.
So, all right, good. I'm glad you're getting confident. All right, that's good. That's
Is
good.
the confidence interval for the upper and lower going to be the same number?
Can you feed them when you're done eating?
Because
Hold on a
if-
second. Hold on, I have to mute. I'm sorry. I can't have people having conversations and something I'm recording and gonna share. Okay, so can you ever have the same confidence, lower and upper confidence? If your data is perfect and you have no deviation, yes. What you have to remember, if you can hear me clearly, so let's go back here on this one. So this is 93.944, and this is 108.06. Now, there's a couple of things I want to explain using this example. You notice how in this one, our standard deviation is 36? Do you remember the standard deviation means that that is how far the scores and average are going away from the mean? Does that make sense to you, what I just said?
Yeah.
So it's an error, right?
Yeah.
Yeah.
What happens if I reduce that error? Just let me play with my calculator. I'm just gonna play with your. You got these numbers written down. That's with a standard deviation of 36. So if I go to stat, I go to test, I'm gonna go to that Z interval, and guess what I'm gonna do here? I'm gonna change that. I'm gonna reduce that. Let's make it a 10. 10. I just took 36 as a standard deviation. I said, forget that. What if it's a smaller sense of error? Look at what happens. What happened to the interval?
Increased.
It decreased. It's much more narrow. Why
I
is
see.
it more narrow? Because there is less.
There's the
Less.
the
The
intervals
standard deviation, I guess,
lower.
when you draw like the chart like you do, I forget what the chart is called, but
The lollipop.
Yep, the lollipop. From the mean, it was 36. Those numbers were spread out a lot more, and then that's why it's closer. That it
Right.
shrunk in each point is.
I shrunk it down to 10. That's the difference of 26 error points, right? So look at what happens if I instead go the opposite route. I don't know if you noticed that deviation is less than 2 points away from each other, right? Did you notice that? That was like 99 and 102. Let's make the deviation larger. Let's increase the deviation to 60. From 36 to 60. Look what's gonna happen. Now, everything else is the same. Whew. Much wider, right? So the standard deviation is toying with you in the background. It's saying that the degree of separation between the average and each extreme, which is the margin of error. Listen to the language, margin of error. What is the standard deviation? It's a measure of error in a sense. The bigger the standard deviation, the wider the interval. Everything else the same, of course, because you have more error, more mistakes. I can give you a real life example of this so that it'll maybe connect for you a little bit harder. You know, I've taught classes where everybody was about the same academic ability, same age group, same academic ability, same standardized scores. I've taught classes where the students might have had the same ages, but oh my God, it's a spectrum. I had from, you know, borderline failure to super academic. What do you think that would do to my grades? Chances are my grades will be much more spread out, right? Because I'm gonna have those failing and those passing with flying colors, as opposed to other classes where my students are more consistent and the separation of their grades might be less evident. As right now, where I'm teaching in one of the colleges that I'm teaching, I have gifted students. The separation of their grades is minimal. My standard deviations are like maybe 4%. That's nothing. I mean, I have 100% students, and then the worst case scenario, 88%. They're very close to that average of 90 something. Make sense?
Yeah, so
As
when you're
opposed to
drawing
my-
that bell in that class where there's a lot of people with a similar grade, it's going to be pushed in, shrunk in and towards the
Correct.
middle, right? Okay.
Well, actually, it'll be left skew, because it'll be higher end.
Oh,
Yeah.
Yeah, okay.
If I was looking at the Olympic runners and their speeds, Olympic runners and their speeds better be right skewed, right? Because I want a crunch in the lower end and really narrow. Because at that point, you're splitting hairs for who's number one, right? Does that make sense into theoretically? All right,
Yeah.
so that's kind of what a confidence interval is. And I've also used the shopping example. Have you ever shopped for something that you're not familiar with? Like, for example, I used to be a heavy gamer. I don't know if any of you are into video games.
Oh, yeah.
I used to love playing video games like Zelda. Zelda, oh my God, I had all the series and I was obsessed with killing Ganondorf. Okay, it's ridiculous. I know. I'm a big kid. But there are other games. And so when you look at the X, there's, what was it, the Xbox, then it was a something else box, and now it's the, I don't know what, rocket launcher box, I don't know. They've changed, they've upgraded. So if I was to go shopping for a video game box now, first of all, I'd be embarrassed because of my age. But second of all, I wouldn't know how much to pay for that, right? So I would ask, hey, how much did you pay? Hey, how much did you pay? Chances are I get a very wide range depending on what I was looking for. Something newer, chances are I'm going to get the price right on the mark because there's no deviation. This is coming out. This is going to cost you, $500, period. Make sense? What I'm saying?
mhm.
Yeah, so that's how kind of like the mindset you should have. All right. How are you feeling?
Well, I don't understand. You got I saw how we got the 93.944, but I don't understand how you got the 108.06.
Okay, that's what I wanted to explain. So let's talk. So on this question, I'm glad you brought me back to earth. This being the average right here. All right, am I sharing my screen?
No.
No. Okay, go back. I had a feeling. All right, here we go. All right, so this being the average, 101. Okay, let's take 93.944 and let's add 108.060. Add those two together. Somebody give me a number. What do you get when you add those two?
202.004.
All right.
202.004.
Let's take this number now and let's divide this number in half. What do you get?
101,002.
Look familiar? Okay, so now you know that. If we take the 108.06 and let's subtract from it the 101, what are you left with? $7.06. Okay, now watch the magic. Let's take the other end. Let's take 101 and let's take away 93.944. What are you left with there?
$7.056.
Which you round to 0.06. So in other words, the margin of error is literally the center point or the distance from the center point. So here's your lower confidence level. Here's your upper confidence level. Here's your average right in the middle. This is the 101. Again, this was 108.06. This was 93.944. Again, the distance from here to here was 7.06. Hence, that is your margin of error. The distance from these two, that's 7.06. Again, that is your margin of error. So the margin of error is always the same distance from the average on both sides. Okay? It is the result of the 1.96 times the square root, which was 36, divided by square root of n, which was 100 in our case, right? Let's take the math, let's do the math for this part. So if you take the 36 and let's divide it by the square root of 100, which is basically 10. So you're basically dividing 3.6 now, or multiplying 3.6 times 1.96, which is approximately 7.06. If you round it out to decimals. So it's the mean, if you recall, we'll go back to the formula, it's the mean plus or minus that. Hence what we just did here, the mean plus or minus that number. Is that making sense?
Yeah.
Yeah, that makes sense.
And that's why the numbers are where they are. Okay. Talk to me.
I just don't know how you, I really get it. I just don't know how you came up with that 108.060 so quickly. You had it before? You had calculated it previously and gotten it, or you actually added 14.12
No, I
in your head?
I literally used the calculator. So if
Miss- Miss
totally
Marie, let me
missed
ask
that.
you a question, please.
go ahead.
I have, with mine, I got 7.056. Is it the same?
Right, we're rounding it to 6.
Okay,
Yeah.
okay.
So that's where, if
So
you
the
notice,
5 becomes a 6.
you round it. So if you notice, I did
Thank you.
just use the calculator there.
Mm-hmm.
And if I didn't, let's say hypothetically, I didn't even have that information, I would have known if I had the margin of error, I just would have done a 101 minus this, the 93.944. And the difference between them would mean that I would add 7.06 to get 108.06.
Yeah.
Yeah.
Awesome, thank you.
All right, is there anybody who's has a learning gap at this point that wants to talk to me real quick about this as we move forward? Tell me.
I could not find out how to take and do the homework, but I did take and do the test, and I got 6 out of 10, which I was proud of myself. But I don't know how to get to the homework.
The homework is, when you open up Alex, the homework is right on your screen. I'll walk you through that after the session.
Thank you.
I may
You
have questions later because I couldn't use a calculator every time I tried to. I couldn't hear you. So if I try to open up another window, so.
We are going to do
But
another
that's-
one. Are you
I'll
ready
check
for
the
another
video
one?
for that. Yes,
Let's
Can you
try
please-
another one.
Yeah.
ahead.
Yeah, can you do another one? Yeah.
Yeah, absolutely. Okay, apparently I have to go into Alex every time because, it misses me so. All right, here we go. I think this is a new one. There you go. All right, tell me, what is the mean? What is the standard deviation? What is the,
point.
go ahead.
The mean is 43.4 hours.
And division
right.
95%.
We want 95% again?
The
95%? And that
And the
means
sample
what?
is 80.
1.96.
The z-score is equal to 1.96. Very good. What's the standard deviation?
9,
9. And what's the sample size?
80.
80.
All right. All right. You want me to do this on the formula, or do you want me to wait for you?
Standard deviation is 80.
Then no.
No,
Look
it's
at
That's
look
the
at the
sample.
Okay.
look at the first sentence and look at for standard deviation.
9 hours.
9 hours. All right. So I hope I'm showing my screen.
Yeah, I
So
see it.
again, our formula, the z-score the mean, plus or minus that critical z-score, which we already know is 1.96 because we were there. And this is over sigma over square root of n. Our mean, unless you're lying to me, you told me was 43.4 plus or minus that 1.96 because nothing has changed. It's 95%, nothing will change, times 9 over square root of 80. You want me to color code it? Will it help you? So there's the sample size where n is equal to 80. Let's color code sigma in orange. That's 9. That's our standard deviation. So standard deviation is equal to 9. Write it down if you have to. It might help you to follow along. The mean is 43.4. Okay. And our critical Z, let's do critical Z in yellow. I think that's what I used last time. So critical Z, which we already studied and we know is 1.96.
Mm-hmm.
So if you follow a regular calculator, I'll tell you what, I'm even going to do this with a regular calculator for you. So take a look up on the screen. I'm going to use just the calculator portion of this. Notice a nice blank, clean screen. Now, those of you that have the plus minus symbol, I don't have that. So I have to literally do this plus and minus separately. So this might be a good example to get you to see. So this, the first part for me, is going to be 43.4 minus, notice that I'm going to do parentheses, 1.96 times, again, parentheses, because I've got a fraction I've got to deal with. I'm going to do 9 divided by, I need that square root symbol, so second square root of, what's our number? 80. Okay, and I have to bump it over a little bit, put the parentheses. That's my minus, that's my lower confidence level. Okay, so you have that on video. You can always go back and see that.
43
What, you need it like that for a minute?
minus parentheses 1.96 times parenthesis 9 divided by second square root
Hmm?
of
Of
80.
80. Yep. Okay, when you hit enter, that should be your first value. So I got 41.427, so 41.4. I'm assuming it
That's
won't.
what I got.
Yeah, cool. Now look at the next line I have, because remember, I don't have that fancy calculator you all have. Notice that nothing changes except for the minus becomes a plus. So I'm just doing this the hard way just to show you that you can do this without the technology. So second square root, again, this should be 80. Bump it out a little bit, put a parentheses twice. Okay, that's what your upper confidence looks like in the calculator. Okay, I'm gonna hit enter. So my confidence interval, when I do this,
5.
the easy way, and you all do it with your fancy calculator, fancy Alex calculator, you'll see that we have the same answer. Do you see that? Are you able to follow that? Is that easy?
I'm able to get the lower confidence level, but without subtracting 41.4 from 43.4 to get the 1.97, and then
You can
add
do
it
that?
to get the 45. And I was able to do that, but like using that stat thing, can you get the upper confidence level, or does that only give you the lower?
Okay, so when it's subtraction, this will be the lower confidence. When it's
Correct.
addition, it'll be the upper confidence.
Yeah,
Correct.
You get both values after doing that stat calculator on the
Yeah.
test and the Z interval.
So
You get-
if you, If you notice, Ryan, if I subtract 43.4 from 45.3, technically, I already have the margin of error. So I just have to take that number and subtract
The
it,
difference?
take 43.4 and subtract that from that number.
Yeah,
So-
I'm getting that. Oh, you know what? When it shows the answer on the stat thing, it says the 41.428. I didn't notice it was a comma and then the 45.372. I thought it was just one whole number that it was giving.
Oh,
Oh. All right.
so here's my, now I'm gonna go fancy pants on you here. Sample size of 80. 95%, they're leaving us there. Look at that. It's the same answer we just got.
Mm-hmm.
Just round the decimal.
Yep. The
All right.
difference.
Yep. All right, so talk to me, people. How are we on this? Are some of you trying your homework as we speak?
Better. I can say it's better.
Getting better?
I'm gonna get
Mhm.
better
Yeah.
once I go into find out how to do the homework. I usually take and go into the modules and do it, but now you'll show me how to get to the homework so I can take and do it all.
You see my mug?
It's through the modules.
Let's
And my
see the-
dog doesn't like you. I
Right.
like that.
All right. Valerie, how are you doing? You're not talking to me. You're good? Kathleen, you're so quiet today. She's not talking to me either.
I'm good.
All right, Don, and you're good? Christopher,
good.
Beatrice, Chad, Nicholas, Michelle, y'all, talk to me if you need me.
I'm good. I'm
Tell me-
good. I
tell me
just
some
I
stuff.
can't show my face right now. Too much in the background, but I'm definitely following you and I'm
Cool.
Hey,
I'm following
Michelle.
along.
I'm
Hey,
good,
how are you,
Professor.
Ronnie?
I'm good.
Good, good.
My
Following
only
along
issue
now.
is that this isn't coming up in Alex for me, this homework. It's like slope of the line and y-intercept and all this stuff that I have to do that I am not.
Yeah,
It's,
it's gonna maybe take you back, but don't leave me at the end of the class and I'll walk you personally. Everybody will get, just to share your screen with me and we'll figure it out.
Well,
yeah, because that's
I
that's
had
my
that-
only challenge is I'm not seeing this as homework for me. It's just slope of
So-
the line, y-intercept and things like that. I'm like,
Correct.
okay,
I
I
think
can.
Ryan has something to share, but see if he helps.
Yeah, that, that happened to me last week's homework and again this week. It's
Yeah.
essentially because if you don't do the whole pie thing at the very
Mhm.
beginning of the class, it
Exactly.
adds that stuff to the beginning that you have to accomplish before you can get to the homework.
Okay.
I
okay.
established
it
that as
adds-
well.
But yeah,
All right. So we'll chit chat after the hour and change so I can let everybody else go. Do you feel confident, no pun intended, do you feel confident enough with this type of example that we've done? Do you want to do another or do you want to move on to the second one?
Miss Marie, I like doing this because I found out how to do it and I got all my numbers and everything. So I feel kind of good. So once I can get on to doing my homework, I'll be doing it right.
Note taken, note taken. All right, is it okay if we move to the next example?
Yes.
Gonna
I
feel
say
okay?
so.
Okay,
I
can I
think
get
I'm
thumbs up
comfortable enough.
across the board? And if you don't, is there a boo one? I don't know. All right.
This is number 2.
Yeah, I think we're good.
All right, so I'm gonna go ahead and then share my screen. We're gonna do proportions next. Now, those of you with the calculator are probably in better shape or just as good shape, but I got news for you. Alex does the same thing. It'll be just as helpful. Watch. Trust me, I'm a doctor. All right, hang on. There you go. Okie dokie, here we go. We're gonna do the second type. I promise you, it's not difficult. God willing, you'll catch on right away. So in this one, you notice it says confidence interval for a population proportion.
Mm-hmm.
Okay. Hey, I didn't write the question, okay? All right, so here's what I want you to take away. And I need you to really read this question. I'll try and make it a little bigger. Give me 1 second. Let me make the screen larger. Okay. When you read this, the first thing I want you to notice is they're going to give you p hat right off the bat. P hat is known as x over n.
Okay.
Well, if you notice, in this case, they're telling you x is 73,
Mm-hmm.
n is 150.
150.
So that means that if there's a p hat, there's a q hat somewhere. So basically, if p hat is 73 over 150, that means that 150 minus 73, which is what?
I got 0.486.
Okay,
It's 77.
77? Okay,
Yeah.
so 77 over 150,
I got it wrong.
Q, and I didn't say that, is Q hat. What I'm getting at is a different concept. Watch what I mean.
Okay.
Take a picture of this question on your phone if you could, or write it down, your choice. If the confidence interval is 90%, what is that critical Z? Do you remember? 1 point what?
1.645.
Bingo. 1.645. That's never going to change. I don't care what the question is. Now, what the only precaution that I beg you to take when you read the question is pay attention to the last lines where they may switch off and try to trick you. So the p hat in this question is focusing on people that favored a new proposition.
Mm-hmm.
So that means that q hat are people that did not favor that new proposition.
That would be.
77 over 150, right? Look, this is where I want you to pay attention, because the question sometimes that they tend to flip it around on you and you think you're answering it correctly, but you're not. But this one is straightforward. So it says, based on this poll, compute a 90% confidence interval for the proportion of all US adults in favor of the proposition. So we're fine, we're golden. Ready? I'm gonna switch pages, so here we go. Do you remember? I said the formula is p hat
Mm-hmm.
plus or minus that critical Z
P hat.
times the square root of p hat q hat as a product over n. Here's what we know.
Square
We
root
know that p hat, which is equal to x over n, and I just wrote this really nasty.
P hat times
This is a little
Q
p hat.
hat
And
over
this is
n.
equal to 73 over 150. Q hat is its complement. What completes this? So Q hat is 1 minus P hat.
over
So in this
n.
case, 1 minus 73 over 150,
150 over
which is
150.
basically 77 over 150.
And Q hat equals
The other thing they need to know
minus
is they
P
want
hat.
90% confidence interval. If that's the case,
1
my
minus
critical Z
73
is
equals
1.645.
150
Okay?
equals 77 over 150. And it's 90%.
Which confidence interval, which means that Z is
Z
1.6.
equals 1.645.
Okay, so that means that our formula reads accordingly. This is 73 over 150 plus or minus the 1.645 times the square root of 73 over 150 times 77 over 150 over 150. It's a little repetitious, isn't it? So use your Alex calculator for those of you that don't have the TI 8384 calculator. Those of you that do have the TI 8384 calculator, get ready. Okay. Write that down, take a picture, do what you need. I'll give you a minute.
73 divided into 150, enter. Plus 1.645
Okay, those of you with the TI 8384, get ready to be wowed.
times
Are you ready? You're gonna go to stat,
second square root.
you're gonna go over to tests. You're gonna go down this time and look at the different tests. So you go Z interval, T interval, you're gonna pass the 2 sample, and there is your the function you need, which is basically the 1 prop Z interval. So hit enter.
Oh,
There's X over N. So that's basically 73 over
okay.
150. And we want 90%. So I got to change this to a 0. So 90%. That's it. That's all you have to do. Go down to calculate, hit enter. And there's your answer. So I believe it was Ronnie who started dividing and got 0.41944, 0.1954, and then the others, the upper confidence is 0.55379. All right, so now we need to look at our question and let's make sure we know what our, how many decimals they want, okay? Who has Alex available that can share real quick? Anybody willing to?
I can't because my homework doesn't let me use the calculator for the slope of line stuff, so.
Okay, are you able to follow along so you can at least come back to this?
Yeah,
Okay, who has access to their calculator?
I do, but I don't know how to get all the answers.
Yeah, but you have the TI 8384, so you're gonna use that one.
Okay.
Anybody have their Alex available, their calculator that can share the screen? No, children don't want to play today? All right,
I can do it.
I'm trying to get back into it.
it's okay. I got.
My session expired, so I'm going back in.
I'm making you co-host. Go ahead.
So we go into stats.
Well, hang on. I'm going to do the
I'm
Alex.
just asking the question. Go ahead. I'm gonna wait.
Nicholas, were you going to share the Alex?
Yes.
Awesome. I made you co-host.
Okay. How do I share my screen?
I think it's towards the bottom. You should see a little green light shine up.
It's green. It's down the bottom.
I got it. Can you see it?
I see your name.
Oh,
Oh,
There you go.
Gotcha. Okay,
So
so
here's-
you're gonna go over here. Let's do a fraction. Let's do 73 over 150. Okay, scooch over and then plus or minus. No, do you have that key? Uh-huh. And then your critical, which is 1.645. Awesome. And now it's times. I need you to hit time, yeah. And then we're gonna do the square root. Parentheses. And now we're gonna do that fraction, 73 over 150. Uh-huh. Scooch over a little bit and then hit times. No, don't close it yet.
Oops.
Because if you close it, it's gonna be a pain. Just do times, and then do 77 divided by 150. Now we want to close it out after you scooch over. No, come back. Scooch over. There you go. And then now divide. Hit the divide key. You need to get over to the right hand. Yeah, 150. So
Is that
that's
it?
what that's what that looks like.
Equals.
Okay, and equals, and there's your answer.
Okay.
0.41954, 0.55379. We're gonna need to round these numbers.
Right.
Okay.
Okay, so far so good.
0.42.
0.4, I don't know how many decimals they want.
3.
I have to go back. So
The
it's
one
three.
says-
three decimals.
It says 3.
That's
So
on
it
my
should be
screen.
point,
I don't know what it was though.
Okay, so let me go back, share my screen. Thank you for that.
Yeah.
So let me go back to the question. So they want 2 decimals. Okay, so 2
2 decimals.
decimals, 0.42 and 0.55. Those are our answers for this.
so the lower is 0.42 and the upper is 0.55.
Correct.
Okay.
So Ronnie, you needed to see the calculator?
Yeah, let me,
Look at here. So you're gonna
Go
go to
ahead.
stat, go to stat,
wait a minute. Okay, wait a minute. I'm on stat.
with your arrow key, go to test,
Okay. I'm there.
scroll down with the arrow key all the way down. And you'll see 1 prop Z interval.
I got it. Hit
Enter.
hit enter.
Mhm.
Okay.
So- And all I do is put in the p hat, which is the 73 over 150
Okay. 73.
over 150.
Okay, go down.
Your count,
150.
and your confidence level 0.90,
0.90.
correct? And then go down to calculate and hit enter.
Yep. 0.41954 and 0.55379.
Yep.
And N is 150.
And they want,
And the other one is 0.486.
which we don't really care, we just want the confidence interval. They want 2 decimals, so 0.42, comma, 0.55.
Yep.
And remember, the margin of error is nothing more than the difference between the p hat and the lower, and the difference between the p hat and the upper. So subtract either one. I tend to always subtract the upper and the p hat, because 0.55379 is bigger than 0.486 repeating. So when I
Okay.
subtract that, I get the margin of error, and now I can just subtract that from the p hat to get the 41,954.
Okay.
They're all related cousins. Okay, so how did you feel about that? Was that
I felt good because you walked me through it.
okay? But I need you to be able to be self-sufficient and do this on your own. When
Well, I wrote it down and I took a picture of it.
all right, I'm
So
trying to
I
get
need
another.
to
Let's try
start-
another question.
doing my homework.
Let me see. Why can
So
I
this
not?
is the conference. Confidence interval.
There you go. Here's another question. Let's try this one together. So what's your p hat? What's your confidence level? What's your q hat? What's your formula, etc.?
Is the P hat 287?
Over 350, correct?
Yes.
And what's q hat?
Oh. Do you take the 350 and minus the 287 or
That's correct.
it's 63?
Thank you. 63 over 350. That's your q hat.
Oh, okay then.
All right. And
So you minus,
what confidence level?
1.654.
1.645.
45, yeah.
That will make a difference in your calculation.
Yeah.
All right. So let's throw this into the formula. What does that formula look like if we write it out by hand? So again, let me just draw a line here. We'll do it in red. So this would
We got-
be p hat. So you start with 287 over 350 plus or minus the critical value of 1.645. That times the square root of 287 over 350 times the 63 over 350. Apparently I start being able to write. And all of that over 350. And that will give you the answer you're looking for. All right, and so throw that into your calculators. Tell me what you get.
I got 0.78 and 0.85.
0.78 and 0.85. I assume you already rounded that?
Oh yeah, I think that's the, I don't know if that's the real answer. I just hope it is.
Okay, so let's see. So it's 287 over 350. 90% confidence. So yes, actually I got 0.79 if you round it. So I got 0.78622.
Right, 0.79 and 0.85.
Yeah, so 0.79 and 0.85 is correct. Because they want two decimals again, is that what it is?
287.
I believe so. They wanted to,
This is what you should have
Well-
in your final answer. That's your confidence level.
I missed the X and the N. I think for some reason I wrote the wrong numbers down. I'm
All right, hang
sorry.
on.
Can we go back to look at
Yeah.
that?
There you go.
Okay.
You can read the question.
is the N always going to be higher than the X?
Oh yeah,
Okay.
yeah. Because it's
Mine
gonna
is wrong. This is real wrong. Clear.
Are you finding this to be manageable for you?
It definitely helps to have the calculator that I do.
Oh, absolutely.
Yeah, the calculator
And,
helps.
and,
Yeah, Alex.
and what were the answers, ma'am?
0.79 and 0.85.
Okay.
I'll do it on the screen if you want. So I'm gonna go to stat. I'm gonna go over to test. I'm gonna scroll down to one prop Z int. This is 287. This will
Oh,
always
wait a
follow
minute. On one prop Z, I was at the wrong place.
one prop Z interval. Remember that.
Mm-hmm.
90% confidence, calculate, there you go. That's why we round this to 0.79 because that's a 6 after the 8.
Okay.
How many of you are using the TI-8384? I know Ronnie is, I know Ryan is. Who else is using it? Nick, are you using?
I
the
am as
TI?
well.
Who is?
Yeah,
I,
I'm
Michelle.
using
Michelle, okay.
Yes.
So
I
you'll
have my own TI-84 at home that I use.
all right, good. Good, so then this is obviously recorded, so you can. All right,
I'm gonna go back and, because I want to make sure I get it right with the calculator.
now what I do want to discuss with you real quick is the interpretation of this. Because it's really fine and dandy that you're computing this using a sample, given the information shown to you. But what does it mean to you to have a confidence interval, like for a proportion in this case? So as an example, if you notice this is your lower confidence, this is your upper confidence.
Mm-hmm.
So this is really in our interpretation, this is really 79% and 85%.
85%.
Because it's a proportion. So we say, in this example, we are 90% confident or sure that the percentage or the proportion
Mm-hmm.
of seniors who believe they will have the fever, string fever, I before E except after C, right?
BLIIEVE. Yep. Mm-hmm.
Yeah. Who believe they have spring fever is between,
79 and 85.
yeah. And just for the record, in politics, this is how they determine, you know, like when we do polls to determine the voter proportions or patterns, this is literally what they're using, this formula, just FYI. So they can tell based on the samples that they're taking what the general gist of the voter trend is. So whenever you hear this in the news, now you know where it comes from. It's not a made up.
Mhm.
Now, the other thing that I would encourage you to do for your own gratification is you saw how I played in the initial example with the standard deviation. With polls, you can change the sample size from like 350, reduce it to 100 in one case, and in the other case, increase it to 1,000. And then this would affect this, and this as well. And look at the intervals and what happens, how they shrink, how they grow bigger. Here's the analogy. The more information I have, the closer I should be getting to the truth. The closer I'm getting to the truth, the less error I have. Does that make sense?
Okay. Yep.
So
does
when
that
you
mean if you
mean
have-
the more information you have, that's the sample size?
Correct. So the larger your sample size, now remember, if you're increasing that to 100 or decreasing that to 100, you have to decrease the numerator as well. So what I'm getting at is that when you look at your sample size, the bigger that proportion is, the smaller your room for mistakes. Because
Would that mean
huh?
if you have a larger sample size as opposed to 79 and 85, would those numbers be closer together? A smaller,
That's what I'm
as
getting at.
opposed to 6%, it'd be less. Okay.
Correct, because you have more information. The more information you're gathering, then the more accurate your analysis should be. If you think about it, go around your neighborhood, please don't do that, but think about yourself going around your neighborhood and asking just maybe 10 people who they're going to vote for. Chances are birds of a feather tend to flock together. So chances are people in your area are going to have similar viewpoints. So you're going to have a very flawed sample. But if you increase that sample to be diverse and randomly selected throughout the area, then the closer you're going to get to the truth, because the diversity of answers is going to mesh. So the bigger your sample size, the smaller that margin of error is going to be, or become, generally speaking.
I have a question
More data. Yeah.
for Alex. It says the knowledge check 1 is due tonight. I don't know if that, I mean, it looks like we have to do it. Is that going to be newer information or just like the same information?
If it's a
What-
knowledge check, it should be a review of what you've done.
Okay. And
Unless it's testing or assessing you to create more of your pie, I mean, that could be
our
that.
knowledge checks going to be, do they count towards your overall grade on the
Not
Alex
really.
homework?
Not really, as long as you keep going.
What if you don't do it? It doesn't, you can't
Nicholas,
do it.
it's not
That's the
hard.
Next level.
Huh? Say again?
That's the next level.
Yeah, won't let you?
No.
My,
it won't
se-
let you
my
pass the
knowledge,
next
my
level.
knowledge check says it's due Sunday, 11:59 p.m.
Yep,
Yeah,
it's
mine's
not
too.
that hard, Nicholas. I did mine today.
Yeah, but
I got
Nicholas, if you don't do it, it doesn't let you pass the next
Doesn't
level.
let you progress.
Right.
Yeah. 'cause it's
I
not-
got 6 out of 10, and I think that's real good for me.
Right.
Mhm.
I think it just says 9:30. That's today, isn't it? So
Yeah.
I think it was
Yeah.
unlocked today.
I don't know why yours
took a
say that.
knowledge check, so I just don't know why there's another one. Is it because you want to make more of the pie like bigger? Like
I'm not the one controlling that. Alex is controlling that, but what I can control is I can push back the due date.
Mine
Okay.
says
That would be
Sunday.
nice.
Is that what you're asking me to
Yeah.
do?
Mine
That
says
would
Sunday
be-
too.
Yeah,
For
and I
some
did
reason,
one,
I
and
had
now I have to
two.
do another one.
And
Okay,
I
sorry.
finished.
One
I'm
at a time.
sorry. I was just trying to say, I had two as well, Nicholas, and that one was due today.
Right.
I finished that yesterday, and then I just went in again. And that's when I couldn't hear her, so I had to close out. But there was another one, so I assume whatever you have now is probably the previous one,
Hmm.
maybe.
Okay. I took the initial one and then it just says I have another one and it's due
Correct.
tonight. But it says knowledge check 1, so, and it says 1 of 1 remaining, so I feel like I already took that, but I don't know.
Yeah, me too,
Yeah.
but I don't know why it's showing up like that
And-
either.
Yeah.
Okay, so it's an Alex thing. It's built in by Alex to check your progress based on your performance.
Mhm.
And it does vary, I think, from student to student based on content. Because everybody scored differently on their PI, so. All right, I'm done at 7:30, so unless you have questions, I would encourage you to stay. Because I'm gonna keep going and I have to talk to a few of you. So in other words, are you good with proportions? Or do you want to
Yes,
do
ma'am.
another?
I'm
You're
good
doing
with proportion.
We're
your
good.
thumbs up?
Professor, I'm gonna email you regards to my Excel because it's saying that it was missing, but I emailed it to you. Well, like I submitted the assignment, but I'll email you. I'll email it to you. What I need to talk to you about.
You can hang for a minute. I'll talk to you right after class.
Okay, no problem.
Yeah. All right, is if you're good, if you need another example on proportions, we can do another example. It's up to you. Are we all good?
I'm okay.
I'm
Good.
good.
I'm gonna be
Question.
good.
Kathleen's
I
good.
email
You're
you
good.
separately
Ron, you're
about-
good. Ryan, you're good. Don, you're gonna wait for me. You're
Yes,
good though, right?
I'm
And
awake.
Good.
Valerie?
I would like to talk to you though.
That's
Yes.
fine. Hang tight. Valerie, are you good?
Yeah, the only thing I need to do, I guess I have to do for the class 5 is I have to do the slope of the line assignments and y-intercept and all that stuff that really isn't covered, but I guess I still have to do that.
Yeah, once you get past that, then I'll take you to what we just did.
Yeah, it's
So
I did that.
foundation. It's
I have to do it
foundation
too,
knowledge.
Valerie. I don't know why. I
Okay,
was
so
getting
everybody else.
frustrated.
Yeah. Okay.
Yeah, I'm sorry, it's foundation knowledge. I mean, I'm happy to happily help you guys if you need help with that, so. Let me know.
No, I just
Okay.
wasn't expecting that to come up the past 2 weeks. I wasn't expecting to see y-intercept, slope of the line and all that stuff. So it was just kind of,
If it's something you're familiar with, knock it out real quick and be done. You should
Okay.
be good. All right, very good. So if you're good with the examples I've done, I'm gonna stop the recording. Last call. Stopping the recording.